Okay, so can I please have your attention? Oops. Before we go to the topic of this week, there are the two announcements. And the first one is I don't really want to postpone the deadline for the assignment again, but unfortunately we have to do it. So because it's next Monday, the coming Monday is a public holiday. So the deadline for the assignment will be the Tuesday, 12 o'clock in the afternoon. Is it okay? The sharp, it means you have to give us the your report before that time. Otherwise, nobody will collect your assignment. So there will be a big problem. And the other one is for the assignment, they are ready for you to do it after more than the 3 months. So I think the time should be totally enough. That's for the assignment. Second one is for the consultation. For this course, I do think there are some good strategy, some amazing way for you to learn the knowledge. I think the only way for you to pass the final examination will be the two parts. First one will be asking question. So we have the consultation in each day from next week. And next Monday is a public holiday, so we don't have the consultation. And then after that, we have a consultation from the Monday to Friday in the next 2 weeks. We try our best to support you before the final examination. If you wanna work hard, we will go with you, and we try to answer all of your questions. That is for the consultation. And for second way for you to pass the examination will be the practice. And for the practice, I promise you all of the questions, answers for the quiz from the week 2 or from the week 2 to the week 12. All of the quiz, question, answer, all of the tutorial question and answers, all of the self-improvement questions and answers will be ready in the next Monday. Because we have a tutorial after lecture, so we cannot make them available now. Otherwise we'll be like, they don't need to attend, they will get the full mark. But all of them will be ready from the next Monday. If you cannot find the question or answer, please give me an email, and we'll fix it as soon as possible. And after that, we support you to do all questions in the textbook. The whole logic is that if you put the effort, we will put the same effort. What we do is that if you want to get the answer for some specific questions in the textbook, please email us your calculation. You email us calculation, we will email you the answer. Is it okay? From the chapter 1 to the chapter 12. So that is the announcement. And for this week, yes, for the past examination paper, we are still working on this part. I will try my best to help you to get the past examination papers. But at this stage, I'm still waiting for the feedback from the school. So, but otherwise, I really want to say is for the final examination, the best way for you to prepare is to focus on the textbook. And I don't really think the past examination, they have some new information for you for this semester. But of course, more practice is always better than less. Is it okay? So now let's go back to the last topic of this semester. In the last week, almost at the end of the lecture, we discussed a little bit of multiple regression. Generally speaking, the only difference between the multiple regression and simple regression is we put the more predictor into the model. For the simple regression, we have only one predictor, that is x1. And for the multiple regression, what we do is we put more predictors into the model in order to explain the variation for the y. The whole idea is actually same. We still try to minimum this value, but the difference is in the simple regression we have only this part, but for the multiple regression we added more predictor inside. That is good. That sounds like we make the model more useful. However, when we put the more predictor into the model, they give us some problem. The first problem is R-squared. When we're talking about the simply regression, the way for us to identify whether the model is good or bad is based on the R-squared. I used to remember this part. So what we do is we determine how good that the lines from the two variables feeds the data is to see whether the R-squared is increased, is higher or lower. If we get a 0.7, 0.8, we believe the model gives us a very good result. If it is only 0.01 or 0.1, which believe like the model, the x cannot really explain the variation in the y. All of them is perfect. However, when we move to the multiple regression, we still use this equation here. But what happened is that whenever we put the variable into the model, the R-squared is always increased. For example, like you want to predict the increase in the stock market. And what you do is you put the variable into your model. In here, that is how many times do you go to the toilet in each day. And then what you found is the R-squared is increased. That's good. And certainly you can put how many times do you go to a specific restaurant into the model, and then the R-squared is increased. And of course you can create more variables. For example, like how many bananas they sell in Africa, or how many apples the people they buy from other countries. And then you can put all of them into your model, and the R-squared is always increased. Do you think it is good? Do you think you should put them into your model? Yes. So you want to use how many times do you go to the toilet to predict the increase in the stock market? We can do some tests. That is right. But we have another way to fix it. That is, we want to fix the R-squared, and that is the reason why we have to design. So how to solve the problem is we will modify the equation of the R-squared, and in order to make it give us more information. So what we do is that This is the formula for the R square. The R square equal to the SSR divided by the SST. And for the adjusted R square, what we do is we rearrange it. This part will be equal to the 1 minus SSE divided by the SST. And what we do is we add the n minus k minus 1 and the n minus 1 to modify the whole equation. The reason is that we use this formula to explain what is the meaning for the overfitting. In our textbook, what they told you is we want to have the adjusted R square. It's because we try to avoid the overfitting. What is the meaning of the overfitting is we cannot put how many times do you go to the toilet into the model to predict the increase of the stock market, because that is not meaningful. So what we do is that the R square in here this y is the error term, the epsilon. At the beginning, when we talk about the regression, there are the 4 equations in our mind. First one is that we have a relationship we don't really know, but this is from our theory. In the imagined world, we believe like we know the relationship between the x1, x2 to the xp with a y, but we don't know them. What we know is that we have this equation. That is from the population. And we can find the x1, x2, x3 to predict y with an error term. Is it right? And then after that, what we do is we have several equations. For example, like in here, in the simple regression, we use these 2 equations to get the value for the coefficient. And when we get the value of the coefficient, we can have this equation, the y hat equal to the b0 plus b1xy. What we are looking for is this relationship in here. But because we don't know it, what we do is we try to use it to estimate the relation in here. But now, for the R square, what they give us is how many percent we can use this equation to fix the data from this equation, but from the sample. Okay, right? This equation for the population. But what we have is only the sample from the. What we have is only a sample from the population. For example, like this is the graph we have used in the first week. This is the population. There will be the average age in the world. We don't know it, but what we know is we can get the average age for the Australia in here. So now for the R square, what they do is we try to find a relationship in here. To make the error terms for the sample is smaller. This is wrong. What we should do is we try to find the relationship to fix to reduce the error term for the population. So on this graph, that will be the trend for the number of variables, and that is error terms. That is residues for the sample, which means when you put the more variables inside, the error terms is always decreased. That is R squared. So what happened is this curve will be for the error term for the population. Actually, after some point, when we put some variables, they should not be in this model. The error terms for the population is increased. Does it make sense? Or you are already lost? If you are lost from the first week, so it'll be a big problem. If you are lost in the last week, it should be okay. If you go back to watch the recording. So did you see the problem in here? No, you don't see the problem. No worries. Let me go back to the beginning. I mean, the beginning of this lecture is not the beginning of the week 1. We cannot really go through them from the week 1. The whole idea between the assembly regression and the multiple regression is we just put the more predictor into the model. Do you understand? It's okay? So now when we can put more predictor into the model, there is a problem. That is how many predictors we need to put into the model. Do you agree with me? Can you put all possible variables into your model? This is wrong. So what we do is we try to find the correct model in here. For the R-square, it works very well in the simple regression. Because for the R-square, they give us the percentage of the X can explain the variation of the Y. So which means when the R-square is increased, the model will be better. Do you agree? However, there is a problem for the R-square is if you put the more variable predictors into the model, the R-square is always increased. You can try it. I mean, you have already learned how to run the regression using this data, so you can go back to do some exercise. You can see no matter what kind of variable you put into the model, the R-square is always increased. So did you see the problem? What is the problem?
The problem is we know the variant have no meaning for this regression, but
the R-square is always increased.
yeah.
So now the problem is the R-square, they cannot give us the correct information. So what we do is we try to fix it. What is the problem for the R-square is what we know for the relationship in here is we can get the value for the x1 to the x3 or xp and to predict the y. But we don't have the data for the population. What we know is only part of the data from population. We call them the sample. So which means we want to use this small sample to predict the value for the population. And for the R-square in here, what they give us is how good of the model to reduce the error term for the sample. It is not population. So which means when we reduce the error term for the sample, it does not always give us a good result. Do you follow with me? The main reason is what we are looking for is the population in here. But actually we don't really know what they are. So what we know is that for the error term of the population, it could be decreased when you put the predictors. They are useful. They are meaning. There is a meaning for them to put them into the equation, and then the number of the error terms will be decreased. But when you put the variables, they are not useful into the model. Actually, the error term for the population is increased. However, the number of the error terms for the sample is decreased. Is it okay? So now the problem is we need to find this point in here. Is it right? If we can find this point, which means that will be the optimal point. But unfortunately, we cannot find it. What's the reason? I give you the 30 seconds to discuss with your neighbors. Sometimes your neighbors will give you the feedback is, what is the hell? What is that? So try to convince him, try to discuss with him or her a little bit. Does it make sense? No. Which part is not really make sense? Which part you are confused? Which one? Multiple regression. So do you understand what is the error term? Epsilon. Is okay to you? Okay. Which part you are confused?
What is the relation between R? Yes, between R and the regression model, and how if we put the prediction.
Oh, okay. For this part, is if you put more predictor into the model, the R-square is always increased. You can try it, but it always increased. So that is the problem. We have to fix it. Is it okay? Make sense to you? Good. Okay, let me go back to the beginning. The beginning of the regression is not the beginning of the first week. Maybe we can go back to the first week. Let's go back to the first week. I mean, actually, I use it. I use it for the second hour. Maybe we can use it now. So for the whole idea for that course is we discuss 2 points, 2 parts. First one is descriptive statistics, and second one is inferential statistics. For the descriptive statistic, we can discuss it later. For the inferential statistics, what we do is we don't know the population here. So what we know is we have only part of the population. We call them the sample. And we do a lot of work in here. We try to use a sample to predict the population. Is it okay to you? So how to solve the problem is, at the beginning, we have only one variable in here. So what we do is we use the X bar to estimate the mu. Does it make sense? We don't know the average age for the population in the world. But what we know is we can calculate the average age for Australia. And we believe it could be used as a predictor for the average age for the population in the world. Does it make sense? Or you can use your average income to predict your income for the next year. But we found maybe we can make it better. What we do is if somebody told me there is an X and there is a Y, when the value of the x is increased, the value of the y increased, and which means we can use the x to explain some variation in the y. Make sense? So what we do is we try to we try to reduce the distance between the observed value to the predicted value. Make sense? So now we have two values. The first value will be the observed value of the y. Second one will be the predicted value of the y. Is it right? And we don't have time to go through how do you get this equation. But when you put the value of the x inside, you will get the predicted value y. And you use the y minus y hat, you will get the error term. The error term is estimated value for the error term in here. The reason why the e hat is the estimated value for the error term is because in here we have a imagined relationship, or we call them a theory, but nobody really knows them. What we do is we try our best to find the truth, to find what is the true relation in here. So what we do is we can get the samples from population to predict it, and if we can get the population, we can get a very good result. Is it right? But the problem is we cannot get the whole population because of some reason. What we have is only a part of the population in here. Is it right? So now, based on this sample, we get this relationship in here, this equation, which means when the x1 increased, the b1 will be increased or that is the value for the b1, the coefficient, will make the y hat increase or decrease. Is it okay? So now the problem is we design a ratio in here that is r squared, the SSR divided by the SST. What is the SSR? Is y hat minus y bar. That is for this model, how many percent we can reduce the error terms for the sample. But this is not for the population. And what happened is when we put the more predictor into the model, for example, like in here, we can have we can have the two predictors, and we can have three predictors, or we can have the p predictors. When we put the more predictor inside, no matter they are meaningful or not, the R square is always increased. That is the problem. If there is a problem, what we should do is we try to fix it. So what is the problem in here? I make a graph. On this picture, that will be the error terms for the sample. And that is the error terms for the population. The error terms for the sample is always decreased when we put the variables inside. Is it right? You have to be very careful because I always made a mistake. So try to tell me if I'm wrong. So you have to be very careful. And because we don't know the population in here, so which means when we put some variable, they are not belong to this equation, belong to the population, this equation in here, which means the error terms for the population is increased. But we don't know them. Right? So what I'm talking here is like already spent half hour, totally nonsense. Because we know the problem in here, but we don't really know the error term for the population. We cannot fix it. So 100 years ago, they are very smart. So they are thinking like, how can we do it? What we have is R squared in here. can we make it a little bit better in order to solve this problem? So what they do is they rearrange the R square in this way. And the only difference between the adjusted R square and the R square is that the adjusted R square will be equal to this part. So I give you the 30 seconds to get the equation from here to here. So actually what they did for the adjusted R square is that they put the number of the observations into the equation, which means when you put more predictors into the equation, and they can explain a lot of variation in the y, which means it is useful for you to put them into the model. However, if you put one predictor into the model, but it not really reduce a lot of the variation, which means you should not include it in the model. Does it make sense? So that will be the idea for this part. This is the value for the R square. This is the number of the observations. And this is the trend for the R square. Whenever you put some variable into the model, the R square is always, the value of the R square is always increased. But it never, but the upper bound, they never touch the 1. It always go to the 0.1999, but they never go to the 1. So how to fix the problem is that they put the number of observations into the R square, and that will be the trend for the adjusted R square. What is the meaning for this trend is that if we put the predictor into the model, and the R square is increased, and at the same time the adjusted R square is increased at the same trend, which means we should put this predictor into the model. Make sense? And however, when the R square is increased, but for the adjusted R square, it is not increased. It is decreased a little bit, which means we should not include this predictor into the model. Right? So now it sounds like we have solved the problem. What we have learned from this case, from here? We have something we don't know in here. We believe that there are something in the world, but we never know them. We don't really know what is a true relationship there. But what we know is only a sample. And which are best, we can find the relationship in here. The problem is solved. And for this part, they call them the overfitting the model. That is the first part we need to discuss for the multiple regression. And apparently, we don't have time to go through all of them. So my idea is that we will go through the most difficult part in the multiple regression, and it's okay. We don't have time to go through all of them, but we'll focus on the difficult part. And another important part for the for the multiple regression is that this is how many people they choose their iPhone, their cell phone, in the week 1. Is it right? Do you think we can run regression by using this variable? The answer is yes. Of course, we can do it. That's the reason why we have to discuss it. But what is the problem is that for this kind of the variable, if we give them a value, for example, like 1, 2, 3, 4, 5, 6, do you think they are meaningful? No. The answer you can find them in the week 1 or week 2 when we discuss about the level of measurement. For this kind of variable, the number is not important. It's not meaningful. So we give them a name. We call them the dummy variable. For this case, it's a little bit complicated because we have the 6 values. We go from a very simply example that will be whether the male or female. So what we can do is that I can ask. I don't need to ask. Actually, I can see whether they are a boy or a girl. So I can see like for the first row who is a boy and who is a female. So for the first, if I go from this side, will be the 2 boys. The first one is a boy. Second one is a boy. And for the third one is a lady. Fourth one is a. So is it right?
I think so.
What happened is it's like when we're talking about the example, somebody argue with me this is wrong, because for the Facebook there are the 56 definitions for the gender, whether they are the male or whether they are female, whether they are boy, girl, or whatever. But so we can assume like there are only 2 different people in the world, that is the male or the female, and I can define the people in the first row is based on this table. So what we do is we can give the value for the male is 1, and then give the value of the 0. Sorry. So what we can do is, if this is a boy, I give them the value of the 1. And if it is a male, we'll give them the value of the 0. So what we can do is we can use only one variable to describe whether they are a boy or girl. That one we call them the dummy variable. Is okay? Do I need to repeat it from the beginning?
So when we're describing a binary variable,
Yes.
we only use one set of
Variable.
variables.
Yes, for a binary variable, they have the 2 outcomes, yes or no. For this kind of the variable, what we need is only 1 will be enough. But what is the problem is if we put 2 of them into the equation. The answer is that for the dummy variable, for the 2 possibilities, we need only 1 variable. But somebody maybe argue like, no, this is wrong. What we should do is we should use 2 variables. That will be more meaningful. For the first column, the vector, that means for the first observation is a boy, second observation is a boy, third observation is a lady, and the fourth observation is a lady, and the last one is a boy. And for the second column will be the first one is not a female, so it is 0. And the second part, for the second observation, it is not a female, so it is 0. Which means we can have the 2 vectors. And we cannot put these 2 vectors into the model. What is the problem is that in this data, if you put these two vectors in your model, the data will automatically drop one of them, randomly drop one of them. Because if they put the two of them into the model, they cannot give you the result. The reason is we call them the multicollinearity, and that is the perfect multicollinearity. What is the meaning for the multicollinearity? This is a word for the multicollinearity. What is the meaning is that? For this case, this is a perfect, this is an ideal situation. From this graph, we can see this is the impact from x and y. This is impact from x2 and y. This is from x3 and y. However, it is not always happened for this kind of situation. What happened is that there is a relationship between the x2 and x3. And if we put x2 and x3 into your model, into the model, it will be very difficult for us to see what is the value for this part. Is it right? And when you go back to check your assignment, you can check. I mean, for the 99% for your model, all of them face this problem. What is the meaning is that in this model, sometimes when you run regression, this impact belongs to x3. Sometimes this impact belongs to x2. This is wrong. So we will talk about how to fix it later. But actually, we don't discuss how to fix it. But we'll discuss how to identify it. But now, let's have an extreme case. If this is x1 and at the same time is x2, if you put these two variables into here, can you identify the impact for the x1 and x2? You can't. Another example is like if I have the table salt, if I have the sea salt, and I put both of them into your dish, can you tell me which one is the table salt, which one is the sea salt? You can. You cannot. Can you? Basically, you cannot. So that is a problem. Because maybe you can find the difference between the table salt is a little bit not so strong, and the sea salt is something like that. Anyway, so the example is that, I mean, if you put them into your dish, you cannot find you cannot find them. And for this case, we call them the perfect multicollinearity. And that is the reason why you cannot put the two dummy variables for only one for the two outcomes. If you put the two vectors in here into your model, you will not get a result. In here, I have several examples. Let me go through some questions together. For this question, do you think we meet the perfect multicollinearity problem? Do we? So how many people believe like there is a perfect multicollinearity problem for this equation? So what was the problem?
Don't understand.
You don't understand what is this part? Okay, nice. Yes, you are right. Probably I forget to mention something before I go to this question. Let's go back to the beginning. We call this kind of situation is a multicollinearity. Is okay? So now for a dummy variable for the two outcomes, we can have the two vectors in here. And we cannot put these two vectors into the model to run the regression. The reason is they are perfect multicollinearity. The reason is you can see for the second vector, the second column, that is based on this formula. When you put the value of the female in here, you will get the value of the male. If you put the 0 in here, you will get 1. If you put a 1 in here, you will get 0. So which means this vector and this vector, they are perfect multicollinearity with each other. But for the multicollinearity, what they described is only the linear relationship. It's not the nonlinear relationship. So for this question in here, are they the linear relationship? No, they are not the linear relationship. So for this case, which means we don't meet the problem of perfect multicollinearity, and you can run this equation. So actually, in the last week, when we are talking about this kind of the case, so what happened? What's wrong? When you're talking about this kind of case, one solution is you can try the square of the variable in here, and then you may get a better result. And that is the reason why you can run the regression with the square of the variable. So the answer for this part will be we don't think this is we meet the problem of perfect multicollinearity because they are the nonlinear function of the x. For the first question here, if you have the monthly data over the 5 years, and how many dummy variables do you need to introduce to test hypothesis? That is all 12 months of the year. They have a seasonal pattern in each month. What is the answer in here? What is your answer? C? So your suggestion is we have a 5 years data and we have the 12 months, and then we need is 12 times 5 equal to 60. Do you think this is right? Only 12. Your answer is 12? When we're talking about the dummy variable, the idea is if we have there are the two possibilities, we have only choose one. So now we have the two possibilities, we choose only one variable. In here, for the 12 months, how many possibilities? We have 12 opportunities. And how many dummy variables do we need? We need 11, right? If you put the 12 inside, you will meet the perfect multicollinearity problem. If you put the 60 inside, what I doubt is how do you put a 60 inside? That is for the question 1. For the question 2, if you have the monthly data over the 5 years, how many dummy variables will you introduce to test hypothesis? for the only 1, 2, 3, 4, 5, 6. 6 months. So your answer is 5. If you put the 6 inside, you will meet the perfect molecularity problem. Sure, so many questions. For the question 3. Oh, that is for the 4 seasons. 1, 2, 3, 4. And how many do we need? 3. So that is for the dummy variables. And let's have a 10 minutes break, and we'll go through the multiple linearity, and then we'll review what we have learned in this lecture. The 5 and the requirement 6. And please go back to go through the beginning of the chapter for the multiple regression. Before you do the multiple regression, you cannot have an idea and then you put any variable inside. This is wrong. What you should do is you must have a theory. You must have this part. You must have this equation in your mind. Does it make sense? This is your hypothesis. This is the beginning of your report and the end of your report. You believe this is the thing you want to find, but you don't really know them, right? That is the first thing you need to. That is the first part. For the second part is when you put the predictor into the model, you cannot put any predictor you like. For example, like how many times you go to toilet. So what you can do is you have to run the correlation between the predictor and the y. Make sense? And after that, you still need to run the simple regression between the x1 and the y. Sometimes we call one of the predictor, we call them the variable of interest. What is the meaning of the variable of interest is you want to identify the relationship between the x and the y. Is it right? So what you do is you run the simple regression. You want to see whether they can give you some intuition. That is the first step, requirement 5. In the requirement 6, you need to put more variable inside. And when you put the more variable inside, the main idea is you want to control the other factors, and then to see whether the x1 makes sense for the y or make the impact on the y. That is the logic between the requirement 5 and the requirement 6. Make sense?
You need to work out the correlation between the variables.
Yes, you need to work. Yes, you need to provide the correlation between the x1 and the y.
Okay.
That is a part of the requirement 4 or 3. All good? Or you are still confused with what happened? One of the students gave me an email to ask me who is the tutor and where is the location for the tutorial in this week. Yes, I don't know. Let me see. Oh, yeah, in this week. So I'm very happy to answer his email, but what I really doubt is whether he can pass the examination or not. This is already the week 12. So that is for the assignment. And now let's go back to the dummy variable or the binary predictor. When we put the dummy variable in here, actually what we do is we just change the intercept from here to here. Does that make sense? So that is the last part for the binary predictor. And for the last part is this is a result from the data. And for the final examination, you have to know all of them, all details for these 3 parts. I think we have already discussed it. This is ANOVA, this is the values from ANOVA, and this is a coefficient. For each value of them, you should know them very well. Otherwise, you will be a problem. So we have already discussed most of them, but we don't have time to discuss the F statistic. So in here, you can see this is the number of observation. Is it right? And after the number of the observations, that is the F distribution. We don't really discuss the details of F distribution. But at this stage, what you need to do, what you need to know is, for this theta output, whenever we have a sample, we have a result. Which means if we have 1,000 sample, we have 1,000 result, right? So which means our result is not reliable. Yes, you are right. That is correct. So what we want to do is we want to take a step back. We want to prove two things. First one, like we have discussed in the last week, that is we want to prove whether the coefficient they are significant. Do you still remember this part? So that is the t test. That is the p-value. Make sense? And another part is we want to prove whether all of those x in here, from x1 to the xp, all of them they are related to all of them should be included in the model. What I want to prove is that I want to prove at least one of them is make the impact on the y. So which means, first of all, I never see which one should be included. I never see which one should be included. And that is the F statistic. So for the F test, we want to prove whether all of the parameters they are equal to 0. That is a null hypothesis for the F test. Does it make sense? This is a little bit tricky. A lot of people ask the question, here. A lot of people ask the question is that we already found the coefficients in here, they are positive, and they are very significant. And why do we need to test they are correlated to they should be included in the model? Because we already found it, they are positive value. So for this question, my answer is that whenever we have a sample, we will have a result. Which means if we have 1,000 sample, we will get 1,000 results, right? This time, if we, for example, like in here for the battery, this time if I get a positive value in here, significant, do you think it is possible for us to get another positive value in the other sample? The answer is yes or no. Maybe you will get a similar result. Maybe you will not get a similar result. So now you may challenge me to see like, okay, if we have the 1,000 results from a 1,000 sample, so we can we rely on the result in here? My answer is no, we cannot rely on the result in here. So what we can do is we want to take a step back. We want to prove two things. The first one is we want to prove for each coefficient, for each variables, predictors in here, they are significant in the model. That is a t-test. Second part is we want to prove at least one of them, one of the predictors should be included in the model. But we don't really know which one should be included in the model. That will be the F test, and this is the value for the F test. And how do we get this value? Is based on this formula in here. The F value is based on the MSR and MSE, and for the MSR and the MSE, it's based on the SSR, SSE, SST. We have already discussed. We don't need to repeat them again. If you're interested, you can go back to watch the recording. For this part, this table is from the simple regression. The reason is I want to show you the difference between the simple regression and the multiple regression. When you go back to the test, when you go back to go through the textbook, you will find there are the two tables. They are very similar to each other. This is the table from the simple regression, and in here the degree of freedom is 1, which means there is only one predictor. That is X in here. So we have only one predictor. So that is a 1. When we go to the multiple regression, it should be changed to the number of predictors. That is the only difference between the simple regression and the multiple regression. Second part, you need to know for the F statistic, what the null hypothesis is all of them equal to 0. And the null hypothesis is not of the HO. So that is a good way to write down the alternative hypothesis. And if the null hypothesis is correct, which means this is a right model, we should not include any X into here. But if the alternative hypothesis is correct, which means we should put one of them into at least we should put one of them into the model. We don't, but you may ask me a question, which one? Let me tell you the answer. I don't know. What we know is that we know at least one of them should be included in the model. That's all. You may think this is a very weak statement, but that is what we can learn from here. So this is only the beginning of the whole journey. There are a lot of the advanced course. If you are interested, I really encourage you to attend them. And gradually you will get more of the tools to deal with the data. But at this stage, what we can do from the regression is to prove these two parts. That is for the F statistics when you go through the textbook. The last part will be the multiple regression. We have already discussed it. And for the multiple regressions, how to test? For the multicollinearity, we will not discuss how to fix the problem. In here, we discuss how to find the problem. How can we see there is a problem for the multicollinearity or not? For that part, we need to use a correlation, and we need to use a VIF. First one, when you run the correlation between those variables, you can see some of them is that they are correlated with each other. For example, like the email and the picture is at 0.36. This is a little bit too much. Let me go back to the beginning of this story. The whole idea is that this is how many people they choose the cell phone. And we can thinking like this is the kind of the scores from everybody to buy the cell phone, which means for the Apple they will get a higher mark, higher grades because all of people buy them. So what we do is we run regression to see the reason why most people they want to buy the Apple, which has a 175 divided by the total observation 237. That will be a ratio. That will be the Y. And then I found the marks for the picture, portability, battery, and message and emails. That is how many people do you like this kind of function for each kind of the cell phone? And then we run the regression in here. That is result. So now let me tell you, there is a problem for the multicollinearity. The reason is very simple. If you pay 1,000, you can buy an iPhone. But for a Nokia, it's only like 100. For Samsung, it's only 50 bucks. So what is the problem is for a cell phone, if it is good, it means everything is good. Do you agree with me? If it is bad, everything is bad. If you spend $50, I don't think there is a very good camera in your cell phone. Is it right? So, which means there is a potential problem, that is multicollinearity. How can I prove there is a multicollinearity problem in this model? First one is I run the correlation matrix. That is what I suggest you to do at the beginning. If there are the two variables, they are correlated with each other, which means there is a potential problem for the multicollinearity. For example, like for the picture with the email, this is 0.36, which means they are correlated with each other very, very high. So now you may ask me a question. What is a value? What is a threshold? Can you give me a value to see it is very high or it is very low? My answer is I cannot. That is very hard to see. Somebody see like 0.5 is very high. Somebody see 0.3 is very high. You will be the decision maker for your assignment to see yes or no, to say whether there is a multicollinearity problem. You may think like this is very subjective. So this is not really a very, very good tool. Yes, I agree with you. So what they do is they found another way to describe the multicollinearity. They give them a name is a variance inflation factor. That is a formula to calculate the variance inflation factor. And what they do is that they can calculate the VAF for each of the variables in here. And if the value is more than 10, most people believe like there is a big problem. So let me repeat what you should know for the multicollinearity. For the multicollinearity, first one is you need to know the definition. Make sense? Second part is you should know how to test there is a multicollinearity, one with the two parts. First one is a correlation. Second one is a VIF. For the VIF, that is we call them variance inflation factor. All good? And that is all for this whole semester. And what I wish is you have learned something from this course. And now let's go back to the final examination. Another part is when you we found another problem for your assignment is that we give you the data code for you to run the regression, for you to do the estimation. However, please be very careful. Those code is based on the data set we provided in my uni. For example, like for the confidence and the prediction interval for the Y, this is a critical value from the T table. When you predict, when you get the confidence interval for your prediction, you need to change the value in here. It makes sense? So what we found is some of you just copy the data code and just run them without any modification. and your result is very wrong. So please go back to check whether you put them into you found the right degree of freedom. For the final examination, the first part will be the coverage. The coverage is already uploaded into my. Let me check. It should be. In my uni, and okay, it's here. That is the coverage for the final examination. For the final examination will be from the chapter 1 to the chapter 13. Is okay? And I have already blacked out the section. They are not on the final examination. It's okay? You don't need to worry about it too much. For this course, it's different with other course. For that course, actually, for the first half semester, for the first 3 chapters, chapter 1 to 3, they don't really have too much information in here. For the chapter 2, maybe they have something like a level of measurement, but not too much. And then for the chapter 3, this is just for the picture. So actually, we just go from the descriptive statistic. Is it right? And after that, what we do is we go to the probability. For the probability, we cut them to the 2 parts because for the different variables, they are very different. First part is the discrete probability. Second part is the continuous probability. So that is all for the first semester, first half semester. And after that, we go to the sampling distribution. The reason why we discuss sampling distribution is we need some good properties from the central limit theory for the hypothesis test and the regression. That's all for the whole semester. For the regression, we cut them to the 2 parts. First one is a multiple regression, and then it's a multiple regression. The reason why. Is there anything very funny? Oh, okay. I'm a little bit nervous when I'm talking about final examination. It seems like you. So, when I came to Adelaide, I'm doing the PhD, and for the first time for me to attend the midterm examination for some course, and they gave us only 1 question. But for that question, for the professor, he told me for himself, he need to spend at least half a day to do them from beginning to the end. But he just gave us 2 hours to do the whole question. And finally, for the whole examination, the maximum is 100, of course. And then the best student, they get only 30. Somebody, they get only 7 or 8 for the 100. It's a good question. I don't want to discuss it. Okay, anyways, so anyway, examination, I understand, is very stressful. It's not really a good thing, but we still need to put them into the course. And for the simple regression to the multiple regression, the difference is we put the more predictor into the multiple regression, and because of that, we found there are several problems. For example, like multicollinearity, a dummy variable, and another one is like the profile multicollinearity. So that is between the chapter 12 and the chapter 13. Is it okay? Oh, another one is for the coverage. The smallest unit will be the section, which means if I black out this section, which means you don't need to go through anything in this section. and then for the rest of them will be covered in the final examination. Is it okay? No matter you like it or not, but that is what we have covered for this semester. I don't want to spend too much time for this part because I think most of you should already know it. Oh, we'll discuss it later. Don't worry about that. So the reason why we discuss it is we want to see the coverage is meaningful, is reasonable. Normally for the final examination will be they have a lot of function. First function is we have to test, do you have enough compulsory knowledge? The reason is that we got a lot of complaints from other lectures about this course. The reason is when you attend the other course, for example, like risk management, for example, like wealth management in China, for example, like other course. When the lecturer asks you, what is the expected value? Your answer is, I don't know. And when they ask you, what is the variance? Your answer is, what is that? When they ask you, what is the confidence interval? Your answer is, can you say it again? So a lot of lectures, they give us the complaint to see, what did you do for the QM? So what you are doing is just sleeping in the lecture room. That's the reason why we have an examination. Which means we can show them to see, like, okay, if he told you they don't know what is the meaning for the expected value, that is what he write down, like when they are doing the QM. That is the first reason for the final examination. Second one, that is the foundation for the other course. If you are good in this course, you will be good in the other course. If you are not good in this course, my suggestion is please do not take other course. I mean, other one is we have a mechanism in the school. Is like if you cannot pass, you have to attend it again, something like that. The last part will be the identification. That is, you come to here, and we have to identify who is good, who is bad. If you are happy to join this game, you have to play the game. So that is for the final examination. And of course, if you get a good mark in here, HD, D, or C, which means like how many % you understand for the whole course. For the asking question, this is very important. There are the 3 ways. First one is my uni. Let's go back to my uni. That is what you should see in your laptop, in your cell phone, or in your desktop. That is the discussion board. There are the 2 discussion boards. The second one is the rumors on final examination. What is the meaning for this part is if you have any question on the final examination itself, please put them into this discussion board, and we will answer them as soon as possible. For example, like somebody told you, okay, for the final examination, it is not a closed book examination. You can bring textbook, or you can ask somebody to answer the question during the final examination, and you can put them into here. I will give you the answer, and that is the only way for everybody in this course to get the answer about those kind of questions. So you don't need to worry about like somebody they have some information but you don't have. It never happened for this course. That is for the final examination itself, and for the other questions, for example, like you don't know what is the meaning of correlation. Please put them into the online office hours for the QM. We are still working on this part. So if you put a question in the discussion board, we will answer them as soon as possible. Is it okay? Pardon? No, you can't. Let me write down them in here, and we can discuss it. That is from through my uni, from email. You can give us an email, and we'll answer your email. But any question about the final examination will be answered in the discussion board. you can. We are very happy for you to give me an email. But what we do is we just put them into the discussion board and answer them there. Consultation, yes, we have consultation every day from next Tuesday. Formula sheet and the probability table. If you go to the assessment, there is a folder is the examinations, and this is a formula sheet for the final examination. It's a little bit ugly. I don't know why. When I scan them into the computer, that is what happened. But it is not a big problem. That is what you will see in the final examination. We input all of them. Is okay? This will be part of the examination paper. So you can see this is the end of examination. So which means it will be part of the examination paper. And as a part of the examination paper, we provide all tables at the end of this textbook. Appendix from Appendix 1 to the distribution, to the F distribution. That is what you can see during the final examination. Actually, for the appendix, you don't really need to use all of them. First one for the first two appendix, there is a very small probability for you to use them. That is binomial probabilities and Poisson probabilities. However, for the normal distributions in here, I can promise you will use it during the final examination.
So C1 and C2, both of them are?
Both of them will be in the final examination. But for this course, we just use the C1. We never use the C2 because we try to avoid the confusion. So that is for the standard normal distribution. For the T distribution, there is a very high probability for you to use this table. If it is a sigma, what you should do? When we do the hypothesis test, no worries. When we do the hypothesis test, if we give you the sigma, you should choose a normal distribution. If we give you the S, the standard deviation for the sample, you should use the T distribution. When we run the regression, all of them should use the T distribution, right? And for the chi-square distribution, I'm pretty sure somebody they will not listen the recording. And what I'll tell you is that you never use it in the final examination. So don't worry about that. And for the F distribution, it could be possible for you to use when we're talking about the multiple regression. So that is for the probability table. For the example of the paper and for the dictionary, unfortunately, you cannot bring the dictionary to the examination. And I don't really see any reason for you to bring a dictionary because all of the words are very simple. So no any reason for you to use the dictionary. That is for dictionary, example of the paper. Okay, before we go to the example of the paper, this is a picture I downloaded from the Facebook or somewhere, and that is my expectation from you when I'm talking about the coverage. So I don't really know what the Tony Albert mentioned, but maybe they are discussed about final examination. So don't give yourself too much stress, too much pressure, and we will help you if you want to help yourself. So that is a picture I found from the internet. Now let's go to the example of the. That is what you will see during the final examination. And totally will be the 180 minutes, and you have 10 minutes to read the whole examination paper. And for the totally will be the 2 sections. In the first section will be like 10 to 15 questions. That is the multiple choice questions. What you should do is you need to choose only one best answer for each question. Probably you are thinking like there are the 2 answers, both of them are correct for this question. And what you should do is you should choose the best one for the answer, for the question. That's the first thing. Second one is you have to write down them in the answer book. We are doing the final examination. You have an answer book, and at the same time you have the examination paper. It's here. Is this one. Very probably for the people who will mark your examination, they will not see your examination paper. All of them will be used as a record. So if you don't write down the answer in the answer book, which means you cannot get any mark. Does it make sense? I understand this is everybody should know it, but I can promise you in each semester, at least 2 people, they don't do it, and finally they fail. So please be careful. For the last part I want to say is, you need to answer the question A, B, C, and D. Somebody they write down like that. What is that? I mean, what happened is that they may argue like, no, this is A. Sometimes they will argue, no, this is not A, this is D. So what I tell you is that for this kind of the answer, the school will decide what is that. And for this semester, we have already told you, you need to write down one of them, A, B, C, or D in the cover case, in the upper case. So if they are not these 4 letters, you will not get a mark. Does it make sense? That's for the first section. For the second section will be like around 8 questions. We call them the calculation and the application. And for this part, you need to write down all your calculation in the answer book, including any tables. If they give you some tables for you to fill, you need to copy the table to your answer book. Make sense? For example, like this is a table in the final examination, and what you should do is you need to copy this table. What it asks you to is fill the table, fill some values in here. What you should do is you need to copy the table to the answer book. Is it okay? And you may not get the full credit if you just write down the final result without the proper calculation process. For example, like for the hypothesis test, if you just write down reject the non-hypothesis, you will not get any mark. So what you should do is you have to go through them from beginning to the end. I'll give an example later. That is the second. That is the other thing you need to pay attention. And you may get the partial marks if the process you use is correct, which means if you have some typo, some calculation mistake, it will still be possible to get some mark. So please write down the whole process. And that is for the section 2. And what you can have is an answer book, a calculator that is incapable of storing text. For that part, for the calculator, you don't need to worry it too much. And I'm not the guy who will be in the final examination, but it should be all of the kind of the calculator. It should be okay. But you cannot tell them iPad is a calculator. This is too much. Or you cannot tell them okay, a desktop, if you can bring it. A laptop is a calculator, of course not. So normally the most of the calculator is okay. That is for the materials. And finally, you can have a probability tables. So that is for the final examination, the example for the final examination. And now let me give you some examples for the section 2, when you do the hypothesis test, that is the whole process. We don't have time to go through all of them, but you can go back to watch the recording. You have to include everything from beginning to the end. If you follow the whole process, you will get some mark. Even you have some mistake. For example, like in here, you get a different value. That's okay. We still give you some mark. But if you just write down the reject non-hypothesis, you will not get any mark. So that example for the section 2. And another one is for the another part for the final examination is if you have any question problem, especially for the coverage. If you believe for some of the part, they are not good enough, what you should do is please give me an email. And I'm very happy to make some video clip and upload them into the YouTube. So you can watch what is the idea, and then you can give me the feedback, and we can working on those parts. And that is all for this semester. Do you have any questions, comments? And finally, I really appreciate your support and your cooperation. Thank you very much. Thank you. I mean, at the beginning, we are thinking we try to stop the whole lecture to find somebody sing a song or dancing. And Wenshou or the Juan, they are happy to dancing. And Anne is want to sing a song, but I don't think it's a good idea. So for myself, I don't really know how to dancing. I will learn one maybe in the next semester. Thank you very much.